Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. How is everyone doing today? Today we're going to talk about logics again, logic gates, and actually this would be more logic blocks made with logic gates. So it is the T-type flip-flop, and why it kind of sucks. Yeah, it's not the best type of flip-flop. At least the two ways that I have designed it here, it doesn't really toggle the inputs. And the reason why I was curious about a T-type flip-flop, if you have an SR latch truth table right here, you have that's not even, you have latch, you have S, R, and you have Q, and you have Q naught. So you have all the possible inputs. You have 0, 0, 0, 1, 1, 0, and 1, 1. So there's all your outputs. So you're on your SR latch, if it was 0, 0, it would be last state on both outputs. If the reset was done, it would be a 0 on Q and a 1 on Q naught. And if the set was pressed and a 0, it would be this way. Q naught would be a 0 and Q would be a 1. But the problem was when you did a 1, 1, you got an invalid state. So this was an invalid state, and it could do a bunch of different random things and you get an invalid state. So what you need is use a system to where it toggles between the, when you press both buttons, it will toggle between on set and reset. So you have the SR latch, and then you can also do it with the R naught, S naught latch, which uses NAND gates. This one uses NOR gates, and this one uses NAND gates. And I'm going to show you here, not on this, I have it already drawn out, but this one uses 4 NAND gates, 2 input, and 2 3 input. And this one uses 2 input NOR and 2 input AND. It's almost like a D latch flip-flop, but a little bit mixed up. Let's go to the overhead camera and go over these two. So I'm going to use my probe here. So this is the one with the 4 NAND gates. You have a 2 input NAND gates and a 2 3 input NAND gates, and you tie B, 2 inputs together for a T signal and 2 inputs together for a clock signal, and you tie T high. So I tie T to 5 volts, and then I'm going to pulse A, and that should get me, if I pulse A, and with the NAND gates giving me the opposite and everything crossed, one is NAND gate 1 is connected to the output of a NAND gate, this one right here, and then vice versa, this one C is connected to the output of this one. So it's going to hopefully toggle these, and it does in some respect, just not efficiently. And then the other version is with the RS latch system, the NOR gates, and you have 2 input NOR gates, and then you set up your SR latch system, and then you take a tap off of this 3 input AND gate off of the first NOR gate, and you do the same for the second AND gate with 3 inputs. You tap it off to this input, and then you just have your clock and your toggle, your T, and then again I tied T high, and you can see that no matter what clock signal I put in, it glitches and errors out. So let's look at the circuit here. Let's plug in my power, turn the power on. Okay, so I'm using a clock pulse. I have a clock here, so we should undo it so you can see all of it. So, okay, so there we go. So I have a clock here, I have a clock pulse, and then I have just a button. So let's look at this one here. This one is the one with NAND gates. It's this one right here. And it's all hooked up. I'm not going to go into the gritty details of how it's hooked up. But if I pulse the switch, you know, sometimes it toggles. Sometimes it toggles. Sometimes it doesn't. You know, it can be a tad glitchy. Now, if I pull out the switch and I hook it up to a clock signal, that is a 50% duty cycle to pin 1. And I plug it into my clock signal up here. You can see that, you know, it's just blinking that one, and we'll see if it swaps. As you can see, it's not, there it goes, it swapped, and then now it's kind of going back and forth and doing all kinds of things. And then if I put it into my clock pulse circuit, it basically generates the same, you know, it's not accurate and whatnot. So let's look at this version with the NOR gates and the AND gates. Same thing here. We can hook this up to the button here with port 1. So we can do the button, and you know, sometimes it works. It works sometimes. And then if we hook it up to the clock signal, you can see how it's a little bit more swappy, but it's still not a good signal. And if we hook it up to the clock pulse, yeah, it's not even. So that is this signal. Even if I plug into 1 and then if I grab it with my finger here, it can make it do all kinds of crazy things. So that is the T flip-flop 2 different ways, with this system here and this system here. It's super glitchy, and it's not really a thing. They call this, it's on the internet, a T flip-flop. I thought it was a toggling flip-flop. I did a fair bit of research, for about 6 to 7 hours of research looking this up, and this is what the 2 different versions that I've seen. So I built them both and found that they are not very good. So I figured I'd share it with you guys. That's going to do it for this video. Links to social media, links to Patreon, also a GoFundMe in the description. Help me afford some singlet test gear. No test gear used in this one except for the singlet SPD3303XE 3 output power supply. Thank you so much, and have a fantastic day.